Let's talk about artificial intelligent image generation and the process of training a model so that you can use the model to give it input in the form of a text prompt and then have it produce unique visions or views of what those words are described in picture form. And we do this ourselves. If you've ever read a book or description of a person, you have these images and descriptions of thousands of people or other things that you've seen in your life, and you produce this visual image of, let's say, what a character looks like in a book. And before they had Lord of the Rings illustrated or in the movie, people probably had their own interpretation of what Frodo Baggins looked like, for instance. But in the process of training a model, the way that it works is this process of diffusion. And you know that's where stable diffusion comes from. And in order to undergo this process, first you have to take the image and the text description of what it means. But you take the image and you have to destroy the information and then see how well you can reproduce it based on that description. So in this case, we're going to take Sad Little Red Rocket by GR. Now, what's the difference between sad and melancholy, or tiny and little? Well, we would learn that by interpreting language over and over and over against multiple images. What's a rocket versus a cat or a pineapple? That's something that is learned, in essence, by the relationships of words and the picture. So we don't just take an image and then copy and paste it into a generated image. It's really taking information about pictures and generating unique views of it, much like you would do, as I described, if you read about Frodo Baggins and created your own interpretation or mental model of what Frodo Baggins looked like. But back to the case at hand with the diffusion, it sounds fancy, but it really isn't. We're going to represent, instead of taking Sad Little Red Rocket and putting it in there and having this watercolor diffuse into the colors that you would get when painting it, I'm going to represent that information in a drop of food coloring. And you can see that it's diffusing out there, and we're going to speed this up a little bit. What would happen over time is eventually you get this blue puddle. Now, there's no way you could ever reproduce this image from this blue puddle. All the information is lost, except when we undergo the process of training. What we're doing is that we're capturing along time slices what the state of the system is, the way that the particles are moving around. And what we're able to do is, based on the description, check to see how well our algorithm is trying to reproduce that image. And it might do a better or worse job. And you're doing this averaged out thousands and thousands and millions and billions of times over different images to create the model weights, which are then used to translate your text prompt into a unique image.